Okay, a histogram. A histogram is just a bar graph. We use bar graphs all the time. I love bar graphs because I think they really show it's very easy to just visually see what your numbers are. So you can use a bar graph. Percentages are on the height of the y-axis, and each value of the frequency is on the x-axis, and you create a bar graph. And it's a really great visual of your information. Remember, we're looking at descriptive statistics, so it helps us to describe to someone who our participants are in our study. Now, frequency polygon is just a line graph. I don't really like frequency polygons nearly as well, but it's just a line graph using the same x-axis, the same y-axis, and just using lines as you place them on your graph. All right, we're going to talk about types of distribution. And I'll try to explain this the best way I can. Distributions can be normal distributions, which are very symmetrical, and you're going to have examples of what a normal distribution would look like, and this is very important on the NCE that you understand normal distribution. Or you can have skewed distribution. They could be negatively skewed or they could be positively skewed, and we will talk about both of them. Okay, a normal distribution is laid out very evenly, and your mean is usually very symmetrically in the middle of your scores. Usually you don't have normal distributions unless you have large samples. Think about all the ACTs in the country. If you looked at the distribution of scores, you would probably have a very normal distribution. But think about scores in graduate school. Now, first of all, you've been selected to be in graduate school. You're trying hard. You're doing well. So in graduate schools, most of the scores are going to be piled toward the end of the distribution away from the mean because everybody's trying to make an A. Now, so what I want you to think about is if the scores are here and the mean is here, and the scores skew toward the mean, I want you to think about it's going to be opposite than what you think. It's the direction of the skew, so it's negatively skewed. So remember that. It's not where the scores are because you're thinking, oh, everybody did well, so that's positively skewed. No, it's negatively skewed because there were a few people that, even though these did really well, there was a few people that didn't do that well, and so the skew is down toward the mean. So that is negatively skewed. So if you're asked this, draw your little distribution and mark it out, and remember it is the direction of the mean. Now, if a lot of people score like 30s and 40s on their test, but we have some people that made 80s, 90s, and 100s, and the mean is right in the middle. So this distribution moves this way, and so it is positively skewed, even though there's more negative scores. So the thing for you to remember, very important, is the direction of the skew is the symmetrical distribution. All right, now we're going to talk about measures of central tendency. There are common methods to estimate measures of central tendency. You all know these. You've heard these over and over again. The mean, the median, and the mode. So this is going to be very common to you. We all know the mean is the average of all arithmetic scores. So the mean is going to be the average of the scores, and you can all find that. The median is the midpoint of the ordered list of values. Whatever they are, you chart the values out wherever the midpoint is the median. Now, what if you've got an odd number, it works out well. If you've got an even number, you're going to have to take the two scores in the middle and average them to come up with the median. So the median is the midpoint. Now the mode. The mode is the easiest measure to understand because all you do is visually inspect it. It's the most frequent scores in the variable. You may have 4 90s, and so that's your mode. So whatever is the most frequent score, regardless high or low, whatever is the most frequent is the mode. All right, variability refers to the extent to which the scores in a distribution differ from each other. If everybody scored well and did well, had a lot of high scores, they're going to be homogeneous or lacking variability. If they are spread out a lot, they are heterogeneous. So variability can be homogeneous or it can be heterogeneous. And there are 3 measures that we're going to look at. All right, the range. It's the simplest measure of variability. So simple. High score minus the low score is your range. And I guarantee you'll have these type of questions on the NCE. The high score minus the low score is the range. Very quick and easy to do. All right, then we're going to talk about the variance and the standard deviation. The variance is how close the scores in the distribution are to the mean. How close they are. You've got the mean in the middle, how close they all are toward the mean. Now, the variance is the square of the standard deviation. And I'll talk more about that. Let's talk about the standard deviation. All right, so there's a very simple formula. We're not going to talk about it here, but there is a very simple formula to find the variance. Once you find the variance, the standard deviation is the square root of the variance. Again, simple formula, and then you find the square root of it, and that's the variance. Now, the standard deviation, which is used a lot, variance is not used as much, but standard deviation is used a lot. It indicates the average distance between individual scores and the group mean. Now, when you look at the normal distribution curve, we'll look at it in just a minute, you will see exactly what percentage of individual falls in each of the standard deviations. If you were taking a national test, you would want to be in a top standard deviation because that means you're way away from the mean. So a lot of times on the NCE, you're not going to have to do a formula to find these, but they may give you the variance and say, what is the standard deviation? And you would have to find the square root. Or they may give you the standard, the square root of that to find the standard deviation. Or they may give you the standard deviation and ask you, what is the variance? And you square that score and you get the variance. I've seen that a lot. All right, not only do we use variance and standard deviation, again, we use standard deviation a lot more. There's something called standard scores. You could take a score from one type of assessment and a score from another type of assessment, and you can find a standard score to see how they relate. And one of those is a Z-score. Another is a T-score we'll look at. T-scores are used more often, but one is a Z-score. If you know the mean and the standard deviation, then you can do a small, simple formula and you can find the Z-score. One thing for you to remember, and I'll make sure that you have that, one thing that you remember is the mean for Z-scores is always 0. Very important. The mean is always 0. So if you move up one standard deviation, guess what the score is going to be? A +1. 2 standard deviations is a +2. 3 standard deviations is a +3. Now, also with Z-scores, if you go on the other side of the mean, -1, -2, -3. So the main thing for you to remember is the mean is 0. Here's a better normal distribution. It leaves off the Z-scores, but there is a really good normal distribution with each standard deviation and the percentage that falls within each standard deviation. But line the Z-scores up with the mean, and that will be 0 at the mean. All right, T-scores, another standardized score, which are really used more widely than Z-scores. But guess what? You have to have the Z-score before you can find the Z-score. It's a simple little equation, but you have to have the Z-score. But the mean on T-scores, which is why it's used so much, is 50. Right in the middle, the mean is 50. So 1 standard deviation above is 60, 2 standard deviations above is 70, and it's the same way. 1 standard deviation below is 40, 2 is 30. So there is a difference of 10 for every standard deviation, and the mean is 50. All right, here's a really great normal distribution with T-scores. And you see the mean is 50, and then 1 standard deviation above the mean is 60, just as I just said. Now remember, and I'm reminding you all of this, with a normal distribution curve, the percentages from the mean to 1 standard deviation is 34.13% on both sides of the mean. From 1 standard deviation to 2 standard deviation is 13.59% on both sides of the mean. And it continues out till you get out to 4 standard deviations, and that's 0.13%. So if you score 4 standard deviations above the mean on the SAT, you have scored the top out of it. Probably almost a perfect score because you're in the top 0.1%, top 0.13% in the nation. So it's very important before you take the NCE that you understand the normal distribution curve, the positive and negative skew, and the percentages that are at each standard deviation. All right, stanines. Nobody uses stanines anymore, but I'm going to tell you about it. Stanines, guess what? Stanines, or the normal distribution, is divided into 9 intervals, each of the width of 1/2 of a standard deviation. So Stanines, the thing that you would need to remember with that, all you would ever be asked is that the normal distribution curve is divided into 9 different Stanines. So I know that I've given you a lot of information about statistics. This is very basic statistics that it will help you when you understand this. You're going to ace the research section on the NCE. So I know this is a lot of information, but it's information as you study it and look at it and compare it, you'll see that it's something that you're going to understand and be able to apply in your life as a therapist.